Namaste, you are listening to Apna Gurukul Maths. We are into the second video for the lines and angles chapter number 6, NCERT class 9th. So in the previous video, we just took an introduction tour and we read one theorem and two axioms regarding linear pair and vertically opposite angles. We even proved the theorem. Now in this particular video, we are going to discuss about parallel lines and its transversal, what are the theorems and axioms related to it, and then we will try to prove the theorems as well. Okay, so let's try to understand what are parallel lines. First of all, you might have been reading this for so long. Still, let's quickly revise it. What are parallel lines? Two lines which never intersect. That's all. As well as I have been discussing this in one of the videos as well, that parallel lines are the lines in which the distance remains the same. Yeah. And then we have something called as transversal. What is the definition of a transversal? There is one line which is intersecting the other two lines at distinct points. A line which intersects two or more lines at distinct points is called as transversal. Now over here, my dear friends, it is not required that a transversal can only be made with two parallel lines. It can be any type of two lines. Over here, as you can see, over here we have line L and a line M, and this particular line which is intersecting L and M at A and B. That is what it means, distinct point. That means it's different point. It should not meet at the same point. That is what it means. For example, suppose you have two lines intersecting, and the third line is also intersecting from this point itself, which we could name it as O. Then this particular line, which we'll name it as L dash, that is not a transversal. I hope you are able to see the difference. Okay. Now, two or more lines is called as transversal. Now, once we have a transversal for the parallel lines, then we observe some amazing properties and some amazing things we will try to understand about that. Before that, we will try to understand what are the different angles which are formed. Now, as you can see over here, line L and line M are parallel lines, or they could be non-parallel as well if if we are just willing to name the angles. Okay, and here we have a line L which is acting as the transversal. Now N, as it intersects these two lines, it is forming some angles. There are a total of 8 angles. So these 8 angles are categorized on the basis of different names. The first category is corresponding angles. When we talk about corresponding angles, students many times students get confused in that. Let me make it very clear with the meaning of that. What do we mean by corresponding? I'm talking about the English meaning. Corresponding means both are in a similar situation. Two or more things, when they are in a similar situation, we call them as corresponding. Now let's try to understand which of the angles over here are in a similar situation. What do I mean by that? Let's try to understand. When you talk about the angle 1 and angle 5, what do you observe in them? They both are on the upside of the line. Yes or no? As well as they both are on the left side of transversal, up and left. They are in a similar situation. That means angle 1 and angle 5 makes a pair of corresponding angles. Similarly, angle 4 and angle 8, if you observe, angle 4 is below the line, angle 8 is also below the line. Angle 4 is towards the left, 8 is also towards the left. So angle 4 and angle 8 makes the corresponding angle. Similarly, angle 2 and angle 6 makes corresponding angles. Angle 3 and angle 7 also makes the corresponding angle. I hope that makes a lot of sense with these 4 different pair of corresponding angles. Let's move on to alternate interior angles. What do we mean by alternate interior angles? Now, alternate means one after the other. When we talk about alternate numbers, 1, 2, 3. Oh, in this, 1 and 3 are alternate. We skipped 2, right? Alternate means one after the other. Interior means which is inside, which is in the inside part of these parallel lines or these two lines. We can say that. So let's try to observe. Over here, 3, 4, 5, and 6 are inside, right? But 4, 3, and 6. So 4, 3. 3 is a very adjacent. 6 is one after one angle. So over here, angle 4 and angle 6. This color I hope is not visible. That's why I change it. Angle 4 and 6 makes a alternate interior angle. Similarly, angle 3, when you go, angle 4 is adjacent. One after that, we get angle 5. So angle 3 and angle 5 will make will make alternate interior angle. Angle 3 and angle 5 makes alternate interior angle. I hope that makes sense. Alternate exterior angle, similar function. Angle 1 and angle 7 forms alternate exterior angles, as well as angle 2 and angle 8 forms alternate exterior angle. Let's try to understand how. Angle 1 and 7. So 1, we are talking about exterior angle only. So we are not bothered about 3, 4, 5 and 6, right? So 1 adjacent angle is 2. What is the next exterior angle? It's 7, right? So that is how 1 and 7, and similarly 2 and 8. Now, angles on the same side of transversal. What do we mean by same side of transversal? That means they are either on the right side or on the left side. Same side of the transversal, as well as they should be interior. So 4 and 6, 3 and 6. That is why it is called interior angles on the same side of the transversal. So angle 3 and angle 6, then angle 4 and angle 5. Yeah, so these are types of angle we have. Based on these types, we have some axioms and we have some theorems. Now, what do we mean by axioms and theorems? It is already clear with that. Axioms are accepted as it is without any proof. Theorems are proved on the basis of the angles or previous proven statements. I hope that makes sense. So let's go on to one of the axioms of parallel lines and transversal. It says that if a transversal intersect two parallel lines, then each pair of corresponding angles are equal. What does that mean? If L is a parallel to M, if we have this situation, if L is parallel to M, that means angle 1 will be equal to angle 5, angle 4 will be equal to angle 8, angle 2 will be equal to angle 6, and angle 3 will be equal to angle 7. That is the property, is the axiom of corresponding angles. Now it's the other way around also true. The converse of this theorem is also true. What is the meaning of converse? Over here I wrote if L is parallel to M, then these angles are equal. Yes, its opposite is also true. What is the meaning of that? If any of the pair of angles are equal, suppose angle 1 equals to angle 5, any pair of corresponding angles are equal, then L is parallel to M. What do we observe? Over here it was given, the first statement, it was given that L and M are parallel. The result was corresponding angles were equal. In the second criteria, the corresponding angles are given to be equal, and the result is both the lines are parallel for which the corresponding angles are formed. And that is how we get the next axiom, which is also the converse of axiom 6.3. So we can also mention it as converse of 6.3, which is axiom 6.4, which states if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. I hope that makes sense. Over here, the corresponding angles are equal. The result is the lines are parallel. These two are axioms. Now, once these axioms are stated, we can go for proving other properties. So over here we have theorem 6.2, which states that if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. What is the meaning of that? In the figure which we saw above, over here, the alternate interior angles, that is 4 and 6 are equal, 3 and 5 are also equal. Let's try to prove it. How will we do? Now, as I told, in proving, we try either take help of the axioms or already proven theorems. Right now, we don't have any proven theorem, so we will take help of the axiom which we have just now completed. The name of the axiom is corresponding angles axiom. So what we have to prove over here, I have named it a little different way, A, B, C and D. So we have to prove that A equals B because they are the corresponding alternate interior angles, and C equals to D. We have to prove that that's the other thing. Now, over here, as you can observe, L is a transversal, M and M is parallel to N. That is the given condition. Yes. Now, when the given condition is very much clear, M is parallel to N, we are clear with what we need to prove. Let's try to get ahead. So now using corresponding angle axiom, what do we know? That angle 1 equals angle C. I will represent it by black highlighter. Angle 1 is equal to angle C. They are the corresponding angles, right? Let's take it as equation number 1. I'm sorry. That becomes equation number 1. Now, since L is a straight line, as you can see, L is a straight line and it is also a transversal of M and N, using linear pair axiom, what do we get? Angle 1 plus angle A equals 180 degrees. If I write angle A becomes 180 minus angle 1. I hope that makes a lot of sense for you. Yeah. So that, let's take that as equation number 2. Similarly, what will we be getting? Angle C plus B. Angle C plus B, as you can see, M is a straight line, so it's forming a linear pair axiom. Now we write similarly because we are using again straight line or over here no transversal, straight line and linear pair axiom. Two adjacent angles on a straight line forms a linear pair. That is why we directly wrote similarly. If you are using the same axiom or theorem in the same problem, need not write it again and again. You can mention the word similarly. So similarly, angle C plus B equals 180 degrees. So angle B will be 180 minus angle C. That is the third part. So since angle 1 equals angle C, we already know by corresponding angle axiom. Therefore, instead of C, can I write angle 1? Absolutely. So angle B equals 180 degree minus angle 1 from equation 2 and 4. Angle 2 said angle A equals 180 minus angle 1. And equation 4 says angle B equals 180 minus angle 1. If the right hand side of an equation is equal, then the left hand side also must be equal. I'll write that once again. Angle A equals 180 minus angle 1. Angle B also in the fourth equation we showed that 180 minus angle 1 itself. If the right hand side of an equation is equal, then the left hand side must be equal. How do we know this? The axioms in Euclid, it's one of the Euclid's axiom that if two things are equal to the same thing, A and B are equal to the same thing, then A and B are also equal. I hope that is very, very much clear for you guys. And that is what theorem 6.2 says. You can quickly take a note of this by pausing the video. That's completely your choice. Or if you have made the notes while I'm explaining, that's really good that you are able to write it down while you are listening. Super awesome. Let's now try to see the converse of this. Over here, we have been given that M is parallel to N, and in the result of that, alternate interior angles are equal. So what should be the converse? If a transversal intersects two lines, and in that situation, we get that a pair of alternate interior angles are equal, then the two lines are parallel. Yep. Over here, what is the condition? The condition is alternate interior angles are equal. Okay, this is the given condition. What is the result? The result is parallel lines. It's just the opposite of previous theorem, and that is why it is called as converse. Okay, I mean opposite means the conditions are opposite and the result is the other way around. Now let's move on to one more theorem of this particular parallel lines and transversal. It says if a transversal intersects two parallel lines, then the interior angles on the same side of transversal is supplementary. Supplementary means they add up to 180 degrees. Let's get into the topic. Over here we have to prove that angle 4 plus 5. In this case, 4 and 5 are alternate interior angles on the same side of transversal, so they are sum up to 180 degrees. And then the next thing we have to prove is 3 plus 6 is 180 degree as well. So using corresponding angles, what do we know? Angle 1 equals angle 5. That's all, right? corresponding angles 1 and 5, they are corresponding angles, so they are obviously equal. We know by axiom. Using linear pair axiom, we also know that angle 1 plus angle 4, by angle 1 plus angle 4, it is forming a linear pair, so they must be equal. We also know that. Yes. So when angle 1 plus 4 equals 180 degrees using linear pair, so from equation 1 and 2, what do we get? That angle 5 plus 4 equals 180 degrees. Why? Let's try to understand it in a little bit detail. Okay, over here we have angle 1 plus angle 4. Let me change the color. Angle 1 plus angle 4 equals 180 degrees. If I try to find angle 1, that will give me 180 minus angle 4, 180 degrees minus 4. And equation 1, it says angle 1 equals angle 5. So instead of angle 1, if I substitute 180 minus angle 4, I'll get 180 minus angle 4 equals angle 5. That is from equation number 1. If I take the angle 4 to the other side, 180 equals angle 5 plus angle 4, and that is our proof. Yeah, 4 plus 5 or 5 plus 4, it means the same because my addition is commutative, and hence the proof. That is what theorem 6.4 says, which says that all interior angles on the same side of transversal are supplementary. Theorem 6.5, which says if a transversal intersects two parallel lines such that a pair of interior angles on the same side of the transversal is supplementary, then two lines are parallel. It's just the converse of the previous theorem which we discussed. What is the condition over here? The condition is if angle 1 equals angle 2, angle 1 plus angle 2 is 180 degrees, then the result will be the two lines are parallel on which these two interior angles on the same side are formed. I hope that makes sense. So theorem 6.6, which says lines which are parallel to the same line are parallel to each other. For example, over here it's given condition if M is parallel to L. That means this middle line is parallel to this L line. At the same time, if M, the same middle line, is parallel to one more line, then L is parallel to N. Yes, that is what is the theorem says. Yes. So if we have to prove this, let's quickly go through that. Since M is parallel to L, since M is parallel to L, then corresponding angle axiom says angle 1 will be equal to angle 2. That is the first equation we got. If we look at the similarly, angle 1 will be equal to angle 3. Why? Again, using corresponding angles. Since M is parallel to N, so angle 1 will be equal to angle 3. Again, from equation 1 and 2, what do we observe? That 1 equals 2 and 1 equals 3 as well. Yes. So since angle 1 is equal to 2 and 3 both, angle 2 will be equal to angle 3. That is what that is what this theorem is asking us. Over here we got angle 2 equals angle 3. That means corresponding angles are equal. So converse of corresponding angles axiom says if one pair of corresponding angles are equal, then the lines will be parallel to each other. Therefore the line L and the line N are parallel to each other, and hence the proof. You can quickly take a screenshot if you want. I have minimized it. Yes, I hope it is taken. Now let's move on to one of the examples to understand this in detail. Now this example, I won't be writing the complete answer. I will just be explaining how can we approach this and how can we do this problem. Let's try to do this. Now as you can see over here, it is given that PQ over line PQ is parallel to RS. That is one given condition. Then angle MXQ is 135 degrees. MYR equals 40 degrees. Then find XMY, which is the angle. So what do? The first thing we do is we make a parallel line. Okay, we make a parallel line which is we make a line which is parallel to PQ. We will name this line as M. So what is the construction we did? We constructed a line M which is parallel to PQ, and obviously by the theorem 6.6, M will also be parallel to RS. I hope that makes sense. Now let's try to move ahead. Now, as you can observe, if these two lines are parallel to each other, what do we get? We can see that my is acting as a transversal. I will extend this my to a little extra length so that it becomes clear. So it is acting as a transversal. Once it is acting as a transversal, angle 40 and this particular angle, I'll name it as angle A. Can you say that what kind of angle they are? Absolutely, you are correct. They are alternate interior angles, and we know that by theorem of alternate interior angles, that alternate interior angles of two parallel lines with a transversal are obviously equal. So what do we get? That angle A equals to 40 degrees. Now, this is not you write in examination. This is I'm just explaining you the problem. Once I discuss the exercise problem, I will give one or two examples where you can understand how to approach this answer. Okay. Then, now again, line M is parallel to PQ as well, right? Wait, while this line became a little bit different, I will extend this line on top and then I'll extend on bottom as well. Now try to understand. If this is the transversal, M is parallel to PQ, what about angle B and 135? They are angles on the same side of transversal, right? So B plus 135 will be equal to 180 degrees. That means angle B is nothing but 180 minus 135, which is nothing but 45 degrees. Angle B equals 45 degrees. So we know that angle A and we know angle B. What is the question asking? XMY, XMY. So XMY is nothing but angle A plus angle B. Yes or no? So since angle A, so angle XMY equals A plus B, angle A equals 40 degrees, angle B equals 45 degrees. So we get the answer as 85 degrees. So the required answer for this question is 85 degrees. I hope this question was pretty easy and you understood well enough. With this, that is it for this video, a short sweet video on parallel lines and transversal. I hope all the theorems regarding this are very much clear to you. Thank you so much for your patience hearing. You were listening to Apna Gurukul Maths, one little step towards success. Thank you so much for being with us. If you have any doubts, do comment in the comment section. I will be very much eager to reply it and solve your doubts. This is Shakti Savarn. Thank you so much once again. Namaste. See you in the next video. Until then, keep smiling. Jai Hind.